So this is going to be our first example of a circuit where we're going to apply this method. Remember that our solution, whatever thing we're looking for, is going to be K1 plus K2 e to the negative t over tau. Now in this particular case, the thing we're looking for is I of t, so that means I of t is going to be K1 plus K2 e to the negative t over tau. And so let's see what we can happen here. So we start out with this circuit, and it said it's been in position 1 for a long time. That means we're in steady state. So let's draw the circuit here in steady state in position 1. And so the thing is when you are in steady state and you are a capacitor, that's going to be an open circuit. And so in this particular diagram here, I want to find out what this I of t that we're looking for here type of thing. But really what I'm interested in is I want to find the voltage across the capacitor at time 0. And the reason this is important is the thing we're looking for, sure, that is current. But this current could change instantaneously. And what that means is that I of 0 minus might be different than I of 0 plus. Now what do I mean by this? I mean the limit as t goes from 0 from the left of I of t might be different than the limit as t goes from 0 to plus of I of t. And the thing is, this circuit right here, this circuit is happening before 0. So that means at 0 it's going to switch. So before 0 it looks like this, and it's not going to be the same as after 0. So if I find my I of t over here, it's not going to actually care. We're not going to care about it. So instead, I want to find the voltage across the capacitor, because we know that the voltage on a capacitor cannot change instantaneously, and so Vc of 0 minus is going to equal Vc of 0 plus. And so we'll just call that Vc of 0, and this is going to be a voltage divider rule here. It would be the total voltage times the resistance we're at over the sum of the resistances here, and that looks like what, 4 volts. So that's my initial voltage here. And then what's going to happen is at t equal to 0 plus, the switch has just happened. You don't have the 12 volt voltage source anymore. It connects straight up here. So let's see what that looks like. Now, because something has changed, it's no longer steady state, I don't lose the capacitor anymore. And so we look at this diagram here. Now, the thing is, I want to find the time constant, and you're always going to look at what happens after the switch happens to find the time constant. And there's this rule that I haven't worked out yet, but I'll tell it to you right now, that if you have a capacitor and resistor circuit, your tau is going to be RC. Now R is really the Thevenin R, and it's the Thevenin with respect to the capacitor, that where it was open before. So with respect to those two nodes, our resistors are in parallel here, and so my R Thevenin is 6K in parallel with 3K. That's going to be 2 kilo ohms, and so then my tau is 2 kilo ohms times 100 microfarads, and let's see here, that's 200 milliseconds or 0.2 seconds. That gives me my tau. To see what happens to find your K1, you need to look at what happens as you go to infinity. As you go to infinity, the capacitor becomes an open circuit here. And so let's find out what is I of infinity going to be. I of infinity is going to be 0. because nothing's going on around here at this point. There's no more source of power, and so that means my K1 is going to be 0. And so finally we can write I of t K1 plus K2 e to the negative t over tau. K1 is 0, K2 we don't know yet, e to the negative t over 0.2. And the last thing we know is that if you plug in 0, you're going to get K2, but what should we get? So let's go up to here and say, okay, what is this current at 0? Well, we know that the starting voltage is 4 volts. That we got from earlier. And so then that means the voltage here is 4 volts. And so by Ohm's law, the initial current, I of 0, is going to be the voltage divided by the 3 kiloohms. And so that's my K2 is going to be 4/3 milliamps. And so the final answer then is IT is 4/3 e to the negative t over 0.2, and my units are milliamps. Now, this was probably a lot to take in at first. Accept that, and then we'll move on and we'll see many examples of this, and hopefully you'll see the kind of steps, and it's very procedural once you get the hang of it, but at first it's this big overload of information. So we'll go ahead and stop here and go on and try a different example.